Hey everybody, it's me again. I thought of something after I finished. I never brought up chi-square. And so chi-square is really important because that is the statistical test that we do. And it's to see if our data, so usually our data is our offspring that we're talking about, if it matches our predictions based on our chi-square. So let's talk about a cross. So let's say I was doing this cross, hybrid cross, which I know I already brought up in the video, and that I expected 9 to 3 to 3 to 1 ratio. So let's say I was doing Mendel's pea plant one, where green is dominant and yellow is recessive. So we'll go like that. And where smooth seeds is also a dominant trait, and wrinkled is recessive. So I would expect 9 of them to be green and smooth. Well, not 9 of them, 9 out of 16. And then I'm expecting 3 out of 16 to be green and wrinkled. And I'm expecting 3 out of 16 to be yellow and smooth, and only 1/16 to have the 2 recessive traits, yellow and wrinkled. So what I would have to do is I would look at my data. So let's say I had 500 of these and 280 of those and 310 of those and 100 of these. I would have to set everything up. And so first of all, my null hypothesis, remember null hypothesis means nothing different or extra or strange or weird or any little hypothesis that you have, none of those are happening. The null is the boring hypothesis. So this is that we will get the expected results. We'll get the 9 to 3 to 3 to 1. If we were talking about null hypothesis with our pill bug lab, the null hypothesis would be no preference. So null is the boring blah, 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 blah. Now, let's say that you have an alternate hypothesis. So I was just reading that students on AP exams were having difficulty distinguishing between the null hypothesis and an alternate hypothesis. My alternate hypothesis could be that I think the soil makes a difference in the expression of the color. So soil changes gene expression, and I expect more green than yellow. That's my alternate hypothesis. That is not the null hypothesis. That's not based on my Punnett square. All right, now let's move on to how you set up your chi-square. So what you're going to do is put in your columns. So I had green and smooth, green and wrinkled, yellow and smooth, and yellow and wrinkled. And I do my O, E, O minus E, O minus E squared, O minus E squared over E. All right, and so first I write in those O's, so 500, 280, 310, and 100. And in order to get my expected, what I need to do is add these up. So let me grab a calculator here. Sorry, got to grab one. All right, so I've got, let's see, 600 plus 280 plus 310, 1190. Now I'm going to take that 1190 and I'm going to multiply it by the odds. So over here to the left, I like to write the odds. So 1190 times 9 divided by 16 gives me, I expected 669 here. And then 1190 times 3 divided by 16, I expected 223 here. which means I would have expected 223 here. And then 1190 divided by 16, I expected only 74 here. And then I would go through and I would subtract, find the differences, square it, divide it by the expected results, and then add those together, and that together is going to equal your chi-square. My degrees of freedom would be 3, because it's always your number of possible outcomes. So I had 4 different possible outcomes minus 1. And then I would go to my critical values chart and I would look and see what number I have to be under. And if I am, if my chi-squared is less than the critical value, then my answer is valid, which means that I got the results that I expected based on my Punnett square. But if my chi-square is greater than the critical value, then it is not valid, meaning I was outside the range of what was expected. So I really don't know if they would give you a chi-square on this, because I just don't think that there would be enough time, and I don't think that they want you to do all that math. But that doesn't mean that you toss away all of this information, because this is really how you evaluate and see if results came out how you expected. So I think it's something that they could definitely refer to and ask you to explain how you do your Punnett square and how you figured out your chi-square based on it, and if your null hypothesis was true or not.